Hello everyone, my name is Digbijoy Nath from Center for Nanoscience and Engineering (CENS) at India Institute of Science, Bangalore, and this course that we are introducing is called Basics of Semiconductor Microwave Devices, and this course is basically a slightly advanced version of a basic semiconductor device, but we will predominantly focus on devices that are used widely in microwave and RF electronics. So essentially in our country semiconductor devices courses are rather few, and we realize that the number of courses that deal with advanced devices are actually even fewer. While there have been a lot of excellent courses on microwave engineering and RF circuit design in the country, we do not have a course dedicated on the device aspects of such microwave or semiconductor applications. So this course is not about microwave engineering. This course is also not about RF circuit design. We will not talk about things like directional couplers or tuners, filters, synthesizers, amplifier design. We will not talk about that. We will actually talk about the devices that go into that. Okay, and we will try to keep it as simple as possible. However, a basic background in semiconductor devices is a prerequisite for this course, which means you need to know the concepts, very simple concepts of say energy band gap, effective mass, p-n junction, Schottky junction, drift diffusion equation. Some of these concepts need to be understood and familiarized before we start this course, because this course will build on those, and we will move into primarily transistors and a little bit of diodes, which are extensively used in microwave electronics. The idea of this course is to actually bridge the or try to bridge the gap that exists between the device community and the circuit and system designer community, because the circuits and system designer for the microwave electronics, for instance, when you design amplifier or the front end receivers or any other synthesizers, oscillators, etc., we treat the transistors as black boxes, or the system designers treat the transistors as black boxes, and as long as a process design kit, a PDK or such design principles are available from the device people, the system designers are okay. They need to know the IV characteristics, they need to know the threshold voltage and gain and some of the things. As long as those are provided, an RF circuit designer or a system designer can easily or comfortably work on designing a low noise amplifier, for instance, or RF circuit. However, what goes into actually those devices, how can you improve those devices, how can you bring a paradigm change in the device is what device engineers work on, and this course will try to introduce those concepts to a system designer. So this course is going to benefit a lot, I believe, if you are a system RF system or a microwave engineer who uses these devices or their PDKs to design circuits, because we will try to understand what goes into making these HEMTs, for instance, or LDMOS that actually are used in power amplifiers, for instance. Okay, so we will try to understand the basic physics behind those. So if you are in industry or strategic sector or an academic community, doesn't matter. If you are a system designer working in microwave or RF electronics, but you would like to have a feel for the devices, then this course is expected to benefit you. If you are an academician teaching microwave or RF circuit design to students, even then this course is expected to benefit you, because you will understand how actually devices are made, how devices are designed and fabricated, and the principles behind different categories of devices that are used in microwave engineering. At the same time, if you are a device engineer or you are primarily into research in academic research or other kinds of research for devices, then this will give you a good food for thought as to how to actually work with RF device, how to understand RF devices such that this become meaningful or useful in the RF system community, because just making devices without understanding the requirements and the specifications of the systems or circuit designer is not very helpful. If you are a device engineer and you are making an RF FET, for instance, or an RF HBT, it is important that we understand what the system designers actually need in terms of say gain or efficiency or linearity. So although we will introduce some of the very basic microwave concepts towards the end of this course, such as transmission lines or coplanar waveguides, Smith chart, impedance matching, and classes of amplifier, we will just touch upon those towards the end of this course, but predominantly this course will be about understanding the transistors and some extent diodes that go into microwave electronics. Okay, so I welcome you to this course, Basics of Semiconductor Microwave Devices. It does say basic because we are talking about the basics of these devices. However, if you are looking purely from the point of view of semiconductor devices in general, then it is a slightly advanced course where you are expected to understand or know the basics of device physics or device operation from some earlier courses. With that, I would like you to welcome to this course, and I hope we will have an enjoyable journey learning and discussing together about semiconductor devices that are used in microwave electronics. Thank you.